Okay, so this is our last Zoom meeting of the semester. Hope you guys had a good semester. I enjoyed it. So the student feedback on instruction closed on the 24th. I thought it was open longer. So I posted that kind of assignment just to get you to go do this. It wasn't really worth anything. And that assignment was due days after the SFI had already closed. So, I got a bunch of emails, people saying I couldn't get into it. I'm sorry. That was my fault. I should have had that assignment due earlier. So the response rate was not great. These are normally open later. I didn't realize it closed that early. And honestly, the SFI doesn't include a lot of course specific questions. I would like it to include more questions. So I'm going to create a survey, make it due before the final, asking course specific questions, what you thought about. Remember at the beginning of the semester, we had the draft group assignment due a few days before the actual assignment. And I only did that for the first few of them, then I stopped doing it. I want to get your opinion on that. Do you think we should have done it all semester? And so forth. So I'm going to ask a few questions, course specific. Of course, it'll be anonymous, so please complete the survey and give your honest opinions, and I'll give a place for you to leave comments. So if there's anything you'd like to tell me, you'll have your space there. Of course, it'll be completely anonymous, so be thinking about that. Okay, remember in the syllabus, I'll show you the syllabus in a minute, but you also see this show up in assignments, the extra credit bump. Right here, that's an extra 2% on your grade if you meet all of these requirements that are laid out in the syllabus. If I can find it. Huh, it doesn't seem to be in the syllabus. What? Now I'm really confused. This should be in the syllabus. Right here with the grades. Okay, and wow, it's the end of the semester. I'm going to have to amend the syllabus to include this in there. It's basically you did everything you were supposed to do. I'm going to pause the video a second. I'll show you. Okay, so here are the requirements. This is from a previous semester. I'm going to copy and paste this into our syllabus. So if you did all of this, you'll get an extra 2% added onto your grade. So if you ended up with an 86.3, then that would bump you up to an 88.3. And to get that, you need to score an average on the homework of 90%. We didn't have any MyMathLab practice tests, so this would just be you did all the practice tests. You didn't miss more than one of the lecture videos. You did all the lecture videos. I allow, well, you missed one. Got a 75% average on the weekly assessments and contributed to all of your group assignments. Basically, you did everything you were supposed to do. Then you get an extra 2% bump at the end of the semester. So remember, I've got a lot of students. It's actually easier for you to check that you meet all the requirements than for me. So what's best is, once we get everything in at the end of this week, check all your grades, see if your homework average is 90% or above, see if this is going to say completed all of the practice tests. Look at all your lecture videos. Make sure you didn't miss more than one. Look at your average for weekly assessments. That should be over 75%. And you contributed to all your group assignments. If you did all that, send me an email. It's easier that way. You send me an email, and then I'll put your 2 points in. Okay. The chapter 23 assessment. I just finished grading this. This is what your solution should have looked like. So we got to decide who's group 1 and group 2 here. I always choose group 1 to be the hot one with the higher sample mean. So your book does this. They use Y bar instead of X bar, but that still means sample mean. Women had the higher sample means. I chose them to be group 1. We define our variable. This step is required. Define your variable. Let mu be the mean GPA. We don't mention our groups there. I don't say women, men, just college students, the entire population. Here are my hypotheses. That's a required step. You have to write that. I type all this in the calculator. That would be under button 4. So I enter everything in. Hit calculate. There's my p-value. Now, they didn't give us an alpha, so we have to choose our own alpha. So some of you chose alpha equals 1% and you ended up failing to reject. That's perfectly fine. You were free to choose your own alpha here. I chose 5%, which is what most people chose. So that means p is less than alpha. We reject the null and accept the alternative. That's a required step. That's like the most important step on the page, is writing this right here. What's our conclusion? Reject the null and accept the alternative. The second most important is, what does that mean? To accept the alternative. That means we have strong evidence. I should say evidence right there. We have strong evidence that the mean GPA for women is higher than the mean for men. You have to say the word mean or average in your conclusion. We're not saying all women have a higher GPA. We're saying on average, women have a higher GPA. Okay, then part 2 here. Our confidence interval should back up what we said up here. Remember, confidence intervals and hypothesis tests are kind of flip sides of the same coin. So this would be button 8, I think. Let's check. No, button 0, a 2 sample interval. So we enter in all of our sample stats, 95%. There's our interval. What does that mean? We're 95% confident that the mean, you have to say mean or average, GPA for women is between that and that, more than the mean for men. Okay, let's look at the practice final. So to study for your final, go through all your notes. You should have been taking good notes all semester. A great way to study for the final is to go back through your notes from the beginning and recopy them and make them neater and fill in all the missing details. That's a lot of work, but it works. If you do that, you're going to score 10 points higher on the final, at least. Something else you should do, absolutely. Go back through all the old tests. Remember, you can review the old tests. So go back, rework all the problems, the ones you got right, the ones you got wrong, figure out what you did wrong on them. Like if we were in a face-to-face class and we had paper and pencil tests, then the day I passed the test back, I would always go over the test. I'm so used to going over tests and showing all the right answers. With these computerized tests, everybody gets different problems. Like you might not even have the same words as your neighbor, because sometimes the questions are randomized, much less the same numbers. So it's really hard to go over the test. I tend to just either like ones that a lot of people missed, go over, or if somebody specifically asks, hey, what did I do wrong on number 7? Then I'll help that person. I don't know a better way other than just generate a random version of the test and go through it. Maybe I should do that. You guys let me know in that survey. But the point I'm making right now is look at your old tests. If you're confused why you got something wrong, feel free to reach out, and I can write up a solution for you, or we can have a Zoom meeting and go over it. Figure out what you did wrong on all the questions. And of course, go through this practice test here. Okay, so let me show you all the solutions. Z-score is always the one you want, minus the mean, the one in the middle, over your standard deviation. So there, that Z-score was 1.67. That means that score, that IQ, was 1.67 standard deviations above the mean. Okay, part B here, now we're going to use that Z-score. We're going to find the percentage of our population that's above that value. This is a normal model problem, chapter 5. So we draw our picture. We wanted to be less than something, so we shaded below. Find that Z-score, we just found it. Normal CDF, smallest thing I shaded up to largest. And we get this big number, 95% of the population is below that. Okay, and then part C here, we wanted to know the percentage of the population between two values. Find both Z-scores, draw our picture, find our Z-scores, normal CDF, smallest to largest. So here we're making predictions about individuals in the population. There are no samples here. It's just a normal model problem. Okay, here we drew a histogram. This is what your histogram should have looked like, because we said use a bin width of 10. This is kind of an ugly distribution. It's almost uniform, really. I mean, it's kind of flat. So down here, describing it, there are a lot of ways. It's not clearly any one. I guess you could even almost argue it's uniform. It's almost flat. You could say it's unimodal. Here's our mode and skewed left. Or I guess you could argue it's bimodal. We got kind of a big group here and a big group here. Here's what your stem and leaf plot should have looked like. Okay, all these numbers we get from the calculator. So you just literally type all these into L1, go to one variable stats on the calculator. That will spit out most of these, not this. Range, you always got to find yourself. Same with interquartile range. Range is max minus min. IQR is Q3 minus Q1. Okay, our different sampling techniques. Remember, we had 5. Convenience sample is you stand in one spot and pick the first 40 people that walk by. You take a convenient sample. It's usually not a good sample. It's a very biased method, or can be very biased. Simple random sample, you put everybody's name in a hat and you randomly draw, or you have your computer randomly generate 50 names. Tends to be statistically the best kind of sampling. It just takes a lot more work. Cluster sampling is you put everyone in a group and you sample entire groups. And each group looks like the entire population. Stratified sampling, you put everybody in a group, but each group is homogeneous. They all look the same. The groups do not look like the population. You separate everybody out. And then you take a small subset from each group. And systematic sampling is you follow some kind of pattern. Every 5th person that walks by, everybody whose ID ends in 7, So here, that would be systematic. Every third person in the room, you're following a pattern. Here, you're putting everybody in groups, but those groups share a common characteristic. Everybody with a red car is in one group. That group doesn't look like the whole population. And take a small sample from each. Here we put everybody in a group, and then we talk to entire groups. That's cluster. So I'm talking to 1/4 of all the statistics classes. Every 10th person, that's systematic. Everybody whose ID ends in 2, that would be systematic. Okay, here we're doing linear regression. Make sure on your calculator that you turn on diagnostic. I mentioned this last time, and look, it's still even there. That's funny. Go into catalog, second 0, catalog, go all the way down to diagnostic on. Should do this before you even start taking the final. Right there, on, hit enter twice. Now your calculator will spit out R and R squared. Otherwise, it wouldn't tell you this number. Okay, so our explanatory variable is our X value. We think it might explain our response variable Y. So would height influence shoe size, or would shoe size influence height? If one's going to explain the other, it makes more sense that your shoe size would depend on your height. So height would be our explanatory, shoe size would be response. So we would type all these numbers into L1, all these, the second row, into L2. Then we do button 8. I don't have all those typed in, but I can show you where you would go over to calculate, down to number 8. You hit enter, go through the whole process. That will spit out your line of regression, your correlation coefficient R, and R squared. So here we got R was 0.99. That's very strong positive. Here was our model. That's our slope. The interpretation there is each additional X makes Y go up or down by that amount. So this says for each additional inch in height, we'd expect the shoe size to go up by 0.298 sizes. For each additional X, Y increases by this. If that's a negative, it would be decreases. This is our Y coordinate of our Y intercept. That says the model predicts if your height is 0 inches, your shoe size is -9. Of course, that doesn't make any sense, but you can't have a height of 0 inches. So our Y intercept usually is nonsense, and that's okay. Okay, now we're making a prediction. So they gave me an X, a height. I just plug that in. Get a value. So this model would predict somebody that's 45 inches tall would wear a 4. If somebody asked me for a residual is actual value from the table minus your predicted value. So we know an actual value for 65, it's size 10. If I wanted the residual, I would plug 65 in here, get an answer, take the actual 10 minus that predicted, that would be my residual. Okay, now we're into central limit theorem. This was chapter 17. Here we're dealing with proportions. So we find our standard deviation, square root of p hat, or square root of pq over n. There's our p. Here we were looking at the proportion of students that drive to school. So that's P. P is the proportion of students that drive to school, 0.45. Q is 1 minus P. So we get this standard deviation. We were asked for a z-score. Z-score is the one we're asked about minus the one in the middle. Central limit theorem says in the middle is P. So I get 0.45 minus 0.45, that's 0. What's it mean to be 0 standard deviations away from the mean? That means you're at the mean. That doesn't mean our final answer is 0. When we draw our picture, that means we want to know what's the probability of being above the mean. That's 50%. Okay, now we're doing a confidence interval for means. So especially on this confidence interval and hypothesis test problems, before you get started, I know I keep harping on this, but it's really important. Decide which one of the 8 different problems you could possibly be doing here. Is this means or proportions? Get in that universe first. This is a mean problem. I know that because it says mean. Interval or test? Well, it says confidence interval. So I know I'm doing mean, and I know I'm doing an interval. Now, how many groups do I have? I got 2. So this is a 2 sample interval. So like you could just go to your buttons here in your calculator and see who has that. They look at 4, 2 sample test. It's close, not quite right. That says test. I want an interval. Oh, what about button 6? Nope, that says prop. Definitely don't want that. What about button B? Let's even go in there. Let's look at button B. I don't have any X's or N's. I've got X bars and S's. That can't be right. Like you can almost kind of do this by process of elimination. Here's what we want. Button 0. Look, that's all the stuff. I mean, obviously those aren't the numbers, but that's all the stuff we're given. Sample means, sample standard deviations, and sample sizes. So here's our N, our X bar, and our S for group 2 and for group 1. So we define our variable, let mu be the mean words per minute. Notice I didn't mention the groups there. I type all that in the calculator and it would spit this out. Notice we got a negative. We got to be careful here. We're always predicting how much higher group 1 is than group 2 on average. What's it mean to be negative higher? It means lower. So we're 95% confident the mean or average words per minute for group 1, women, is between 2 words per minute lower up to 6 words higher than men. Okay, now somebody makes a prediction that women are 5, on average, 5 words more than men. 5's in the interval, it's possible. If they make a prediction outside the interval, you don't believe it. If it's in the interval, you never say you believe anything. Never accept. That would be accepting a null hypothesis. If somebody makes a claim, you never accept their claim. You either reject it or fail to reject it. So we would fail to reject that. We just say, yeah, it's possible. Okay, I mentioned this last time that back in the day, we used to do these problems by hand. You would not be required to find the standard error and like to do all this by hand. You would just type all this in the calculator. Like, hey, we can do it real quick and only take 10 seconds. So here we want to, our ultimate goal is to find a 95% confidence interval for Valencia students that have taken this course. Successes have taken the course. So let P be the proportion of students that have taken the class. I'm doing a 1 prop interval. So that's button A. Remember, X is the number of successes in the sample. 25 people in my sample took the course. N is my sample size. There's my interval. So that's all you'll be required to do. You don't have to go through all this work here. You could if you wanted. So we get our interval. Notice I rounded right there, no big deal. So we're 95% confident between 11.9 and 24.9% of students have taken the class. Now, what if we want the margin of error? If we did it by hand, the margin of error was one of the intermediate steps. If we use the calculator, we got to go through extra work to find the margin of error. And that's high minus low over 2. Okay, question 9. Again, decide what kind of problem you're doing before you just start plugging numbers in the calculator. Now, everything we've done so far, like test 3 was all proportions, test 4 was all means. Now it's all mixed together. So here, they don't give me a standard deviation. They don't say the words mean or average. This is not a mean problem. It's a proportion problem. The fact that they're giving me percentages is a big indicator of that. So define our variable. Let P be the proportion of students that have watched Walking Dead or that do watch Walking Dead. We have 2 groups, men and women. Men had a higher success rate. So I call them group 1. Their success rate was 36% versus 27% for women. Here are my hypotheses. Remember, these are all P's now, not mu's. We would type all this in the calculator. This would be button, let's see, this is a 2 prop test. That would be button 6. So we would just type in our 4 numbers, make sure we have the right hypothesis, hit calculate. That spits out our p-value. We got a high p-value, 16%. That's a giant p-value. Fail to reject the null. So we do not have strong evidence that group 1 has a higher success rate than group 2, which is what this says. And finally, number 10 says the word hypothesis. So you shouldn't be doing an interval. I see the word standard deviation. I know I'm in a mean universe. It's going to be a mean problem. How many groups do I have? How many different standard deviations did they give me? Just 1. There's no way this is 2 groups. They didn't give me enough numbers. This is a 1 sample t-test. That's button 2 on the calculator, the t-test. You should keep a list. You should write that down in your notes somewhere. Remember, the title is open notes. Write down which button does what. That's t-test. Okay, so define our variable. Let mu be the mean GPA, or GPA, miles per gallon, that this fleet of cars gets. Here are our hypotheses. We thought our average was 35, but the sample says no, it's not. It's less than 35. We draw our picture. See, here's our sample average. Right in the middle is 35. Our sample says we're only getting 32. We always shade a tail. Notice I shaded to the left and I wrote below. We type this in the calculator. Let's actually type this one in because I want you to see that on the calculator. So t-test, this was 35, 32.05. 483 and 75. And we chose right there, less than. Hit calculate. Look at that p-value. It is not 6. You will never, ever have a p-value bigger than 1. You shouldn't even get a p-value bigger than a half. If you get a p-value bigger than 0.5, you've goofed. That's 6 times 10 to the negative 7th. That's incredibly small. So we reject the null and accept the alternative. We have very strong evidence that the mean is below 35. So they failed to meet their goal. Their goal was 35. Okay. Like I said, I'll add in that extra credit bump into the syllabus. I don't know how that got deleted out of the syllabus. Like that's something that carries over from semester to semester. And if you have any questions, send me an email. Have a good holiday. Study hard for the final. We should point out when the final is due. It opens Sunday. I think it's open Sunday through Tuesday. Let's see. I don't know why this calendar takes so long to load. Yep, Wednesday. Final is due Wednesday. Said it'll be open Sunday through Wednesday. And of course, you cannot give or receive any help on the final. You can't use any outside resources. Don't cheat on the final. You've come this far. You don't want to fail the class and get kicked out of school right at the end for cheating on the final. All right. Recording.